we need BIM, or Building Information Modeling. But I think now the terminology has been slowly changing to digital twin. So digital twin is not invented by Bentley. So it's a term that is being used in the industry to, it means different thing. But in Bentley, it just means that it's a digital representation of your asset, not only the geometry part, but together with all the data as well as intelligence. So depending whether which project life cycle you're in, those information should be in the digital twin as well, and it should be always evergreen. So what is driving all this so-called intelligent modeling? So essentially, it's driven by the owner themselves, due to the ISO 55000 or 55001. So due to what they need to operate their plant during the operation and maintenance phase, that drives now on what the engineering design firms or the construction firms need to deliver to them as an as-built. So it's not going to be traditional PDFs or 2D drawings anymore. More and more industry as well as projects are demanding that they deliver an intelligent model that they can immediately use in their O&M systems. So this next 3 short videos just to show what actually Bentley can provide. So this is a brownfield project as of a substation. So this is an old substation where the as-built may be no longer reflecting what is on site. So the first thing a company needs to understand is what is as is outside the site. So Bentley has a technology where we can convert 2D photographs, or even if you do laser scanning, into a 3D mesh model to understand the actual condition at site. So you don't have to do the traditional inspection or measurements. You can use the reality mesh and look at what is as is from the comfort of your office. Now, with this reality mesh, the next step is that, let's say you want to do a revamp. You can use the reality mesh into your design tool, cut out the equipment or the structure you want to replace, put in the new design, and ensure that it doesn't have any clashes before actually it's being passed on to the construction phase. So that's one use case of this reality mesh. Another example is that for owner operator, you don't have to build the intelligent 3D model again. You can use the reality mesh and then just put in the information that is required for the operation and maintenance, maybe the tagging and certain equipment information, or link it up to your business systems like SAP, your maintenance system like Maximo, or even to your SCADA system or DCS system. So the idea is to have a single platform or visualization into your different information or data that currently reside in different systems in silos. So that is another use case of this reality mesh. So as Vincent mentioned, Bentley is an engineering software provider. We provide software as well as services to help our users design, build, as well as operate their assets. So Bentley is a US company. We have alliance partner globally. I won't go into much detail in this. You have seen this from Vincent. What I want to highlight here is that whatever project or whatever project life cycle that you're in, what's important is actually the connected data environment, how you actually help your different teams or different disciplines to get access to the information that they need, and also to ensure that the information they access is the right one and the latest one. So this digital twin, as I mentioned before, is a digital representation, and it should be evergreen, so it's continuously surveyed. So what information is in this digital twin? It could be your engineering information, whether your P&ID drawings, your equipment data sheets, or it could be also linking to your operations, your SCADA system, DCS systems, or if you have a continuous monitoring of your scans of your existing assets, you also link to your business or maintenance systems. So that's the different engineering data, operation data, as well as the IT data that needs to go into this digital twin and to maintain it to be evergreen. And once you have this information, you can use this digital twin for different purpose to monitor construction, do construction simulation, or even just monitoring and look at the reliability of your assets. Now, one is the digital twin, and also not only having the digital twin, but how your workflows, your current workflows that you do in your engineering organization, that also likely will need to change to a digital workflows as well, utilizing all these different software solutions. So achieving that is challenging from different many companies or users because change is always resistance. So Bentley have helped our users to actually on this journey to how to achieve this digital transformation. Now coming back to plant design, this is an example of architecture where I mentioned before this connected data environment is important to have a single place where you can actually store all the information required by your different teams or different disciplines. So this connected data environment is what we call the plant site. So this is like you can say a project or plant database sitting on this on the cloud. So this is a cloud solution. Project wise is helping on the collaboration side. For example, to ensure your digital workflows, if you have a drawings that's being issued, what approval workflows they need to go through. So all those will be handled by project wise and ensuring the different versions of a particular deliverable. Now, communicating with this central database or connected data environment will be your different applications, whether you're doing PNID, 3D modeling, structures, raceway, cable management, or your architectural designs. It could be Bentley software, but it's more importantly that this connected data environment needs to be open as well to third-party software, which it is. So one advantage of this plant site is that not only it works with Bentley software, but it works with third-party software, whether it's Aviva, SmartPlant 3D, Revit. So it has the ability to take in this information from different software sources. So drilling down a little bit deeper, this is just an example architecture of the different application that Bentley has. So OpenPlant is the heart of the plant design software. But of course, if there are something more specific, like you need to do the electrical cable tray detailing, BRCM is used. Or you need to do some site design, Open Site Designer will be used. And if you need to analyze in terms of pipe stress or your structural stress later on, that we have separate sessions by Madan. So Autopipe and STAT are the application that do the analysis. So all these applications talk to each other and exchange information through this connected data environment. So the plant site is a single portal, web portal. It's a cloud-based solution. So it's a single point where you can access all the information that the person needs depending on his role. So you can configure the role-based security as well. And the whole idea is to make sure that the person that needs the information gets the information quickly, easily, as well as the accurate information is the latest so that it can help with whatever decision that he need to make faster. So as I mentioned before, not only it works with Bentley design solution, it also works with third party like SmartPlant, Revit, Aviva. So all this information, we use bridges to actually transfer the information, the geometry, as well as the intelligence into plant site, which the technology we use is the iModel Hub. And this plant site is open. So you can actually write your own application if you decide to do so to actually interrogate or manipulate this information in the iModel Hub or plant site. So the link here shows the different bridges that we have to different third-party software. Now, coming to the plant design, these are just some of the challenges that some of our typical users will face in terms of during, if it's a brownfield, the initial part is to understand what is as is, because the current as built is no longer matching. And also they have issues with different data from different sources, how to optimize the layout. Then they have to deal with different contractors or subcontractors, the collaboration between the different disciplines. So these are just some of the list of the challenges that typically our user face. So the first one is understanding the actual site conditions. So as I mentioned, we have the ability to convert 2D photographs or point clouds into a reality mesh. So this is utilizing context capture solution in Bentley. And very quickly, you can capture the photographs or point clouds, and then the software itself will convert it to a reality mesh. With that, you can understand what is as is on site. So this is just a short video showing that. Let me just fast forward it a bit. So you can just create a new connection, then you can upload your reality mesh. You can share it with people within your organization, or you can allow your subcontractors or third-party organization to view it as well. So all these are just using a web browser to access the information. So this is one example of a reality mesh that is captured. And from here, you can actually do measurements, understand what is there before, and you can do planning for your revamp, for example. Now, the next example shows a tank where they want to replace this tank. First, they did a context capture of the tank, change it to a reality mesh, bring it to a design tool. Then they can cut off the old tank and then insert the new tank design. So let me just fast forward this video a bit. So this is using OpenPlant, put in the new tank, the attributes, then they can do the new piping and then check for clashes of with the existing structure. For example, if they are maintaining the old structure. So putting out the new piping. Now here you can see that very quickly clash with existing structure. Then you can modify the piping. And also you can design the support for the piping as well. Then once you have the design, you can quickly also extract the isometric drawing of this new pipe, for example, as a deliverable. Okay, this is the example of the isometric drawing that was automatically created from the 3D design. So all this template layout, you can actually define upfront according to your company standard. So in OpenPlant, we have different modules that we broke up to modeler for 3D modeling, P&ID, support engineering to design these supports. Isometrics and autographics is to actually automatically generate the piping ISO drawings as well as the general arrangement drawings. And of course, it's integrating to PlantSight, which is the project database. Now, this first video shows the P&ID application. You can design the P&ID in OpenPlant P&ID. It will synchronize with PlantSight, which is the cloud database. You can publish it to a PDF where maybe the checker or the reviewer needs to look at it. And then within the web browser itself, there's also capability to do markups. And all these markups or issues created will be recorded, and then you can assign it back to the engineer to make changes. So in this video shows an example that the reviewer did a markup just via a web browser looking at the P&ID, and then they create an issue and assign it to the designer. Then the designer will get a notification on the comments, and then he can go back into OpenPlan PNID to make the changes. And once they make the changes and synchronize with the plant site, everyone can see the updated changes. Okay, I just fast forward this video a little bit. It's essentially putting in the changes and republishing it to the plant site. So in plant site, you have both the 3D view as well as the 2D PNID view. And then you can navigate between the PNID as well as the 3D object and vice versa. So this is a very good platform that actually allows different disciplines to do design review meetings. So very quickly they can understand and the design itself, and then create issues if necessary during the design review meetings. Now, as you can see, we have modified the PNID. However, the 3D, we have not created the parallel pump. So there will be highlighted to the designer that the PNID and 3D are not synchronized. He can then... sorry, is there a question? Okay, so it can go into the OpenPlan modeler, the 3D application, to actually just insert, because the software itself will let him know that, okay, this pump tag that is not placed in 3D, he can just right click and then place it into the 3D location. And this plant site allows the user to check out maybe certain pipelines, certain areas, or certain components that he needs to do modification. So it allows different users to actually work on the same project at the same time. But of course, the component that is checked out is no longer be able to be edited by the next person, but it can be referenced by the next person. And once they have done this 3D modification, when it's synchronized with plant site, immediately all users will be able to see that already updated in the model in the cloud. So this ensures that everyone that has need access to the model always get the latest information and the right information. Now, of course, these are the PNID and 3D modeling, and a lot of our projects actually look at what are the deliverables needed. So here are just some case studies that actually help our users to get benefits by using our OpenPlan tools. In this case, they did PNID, and this user actually saved 1.8%, which is equivalent to a 78 million RMB in terms of the total project cost. Here's another example of our user, Sisti. So it saves about 433 hours in terms of coming out with the deliverables. Now, with any database, you can do reporting. So you can extract the line list, equipment list, or even the bill of materials or material takeoff from plant site. You can also extract detailed support drawings using OpenPlan Support Engineering. And the other two common deliverables would be the isometrics as well as the GA drawings. So in this video shows the example of extracting the ISO drawings. You can extract it through OpenPlan Modeler, or you can actually directly access to the plant site database and do batch extraction of the isometric drawings. So in this video example is doing it in OpenPlan Modeler, selecting the pipeline. Then of course the format you can define upfront of the different templates. Let me just fast forward this video. So this is an example of the isometric drawings. So this is an intelligent isometric drawing. So all the material takeoff related to this ISO drawing are available within the drawing as well. So the intelligence are embedded into this drawing as well. So whenever you make changes to the 3D, all these drawings can be automatically updated as well. So you don't have to go back to make changes in all these 2D deliverables. So similarly, you can actually go into plant site, your project in the cloud. You can share your different deliverables or isometrics that you created. And same thing like the PNID, the reviewer can actually access this PDF, review it, and do the markup here. And the markup will create an issue and will be assigned back to a particular designer to make changes. So all these issues are actually captured, historized. So at any one point, for the project manager, it's very easy for him to understand how many issues are open, how many issues are addressed, how many issues are late, or how many issues are due coming up. So in terms of project monitoring or project reporting, this is also a very useful tool. And for the reviewer, it doesn't need to understand the 3D application or the PNID application. All he needs is just a web browser. So the person assigned to be able to see the issues. He also can track the issues within the applications. Then he can go and make the necessary modification based on the issue raised. Then he update the issues, and that will be updated into the issues system as well. So these are some examples of our users. In this case, Tetra Tech managed to save about 250,000 USD by actually creating all these isometric drawings, which reduce their generation time of from 3 hours to 1 hour per isometric drawing. Similarly, for autographics, of course, at the beginning, you need to define your format of the autographics drawings, but after that, extracting the autographics will be very simple. All the annotations, measurements are done automatically onto your isometric drawing. So we have a lot of configuration variables that you can actually manipulate how you want to see your general arrangement drawing. Let me just forward this and give you an example of the GA drawings. So all these are automatically generated based on the configuration that you have done upfront. So this saves a lot of time manually drafting all these GA drawings or manually cutting all these GA drawings from the 3D. And all the outputs, you can actually decide whether you want to save it as a DGN format or you can save it as a DWG format, assuming your subcontractor needs it in an Autocad format. You can do that as well. So the output, you have different various format that you can generate the output to. So similarly, the PDF can be reviewed and then do the markup online and then assign it back to the designer. So the idea is to have a system that actually provide paperless kind of deliverables. So PlantSite is the central database where this digital team reside, and all your team members or even your subcontractors or the owners itself can access to look at the latest design or information. With that, let me just give you this short video on PlantSite on its capabilities.
Hi Greg, great to be here. I'm looking forward to share some of the latest capabilities that our users are excited about. Digital transformation is an important strategy for industries and provides them unparalleled opportunities as they navigate dynamic market impacts. The vast majority of revenue, especially for extractive and manufacturing industry, is earned from brownfield assets that have been in operation for more than 20 years and many for much longer. When we talk to these organizations about their digital maturity, many are struggling to bridge the gap between what was originally designed and the reality of what is actually in the plant. Our users, both EPCs and owners, tell us that one of the reasons they selected PlantSight is because they could start their digital transformation journey at any phase of the asset life cycle. Building an actionable and sustainable digital twin of a complex industrial system is easy with the help of PlantSight's cloud-based portal. With PlantSight, you can leverage all of your existing engineering data and asset management systems and aggregate them into a digital twin. Even if you don't have an existing 3D CAD model, you can create an intelligent 3D reality mesh from laser scans and 2D images. Combine the reality mesh with digital engineering models and get a single visual representation of the data. A process and instrumentation drawing, P&ID, is an important document. It is a blueprint of every process and power plant and comes in a variety of quality, symbol palettes, and overall complexity. Access to an up-to-date P&ID ensures safety of personnel and assists engineers in understanding the plant's operations. These documents, typically stored in vaults, require workers to physically retrieve them. This is not only time-consuming, but also makes tracking changes difficult and error-prone. To solve this, alongside our reality data solutions, we have developed powerful AI and machine learning tools to extract meaning and understanding from these analog documents. While many companies are currently spending days having humans painstakingly recreate each raw document in a design application to make them intelligent, our approach here completes this task in mere minutes. This revolutionary patented technology makes the benefits of a digital twin immediately accessible to existing plants and unlocks latent value for our users. By integrating this output with PlantSight and AssetWise, we provide owners and operators a solution to efficiently realize the digital twin, empowering them and their teams to make informed decisions and take corrective action. Digital transformation at its core is about change. An impactful change for operating assets comes from reinventing tradition and reimagining existing workflows. To make this possible, we are working with leading organizations to bring all this information into the immersive HoloLens experience, enabling them to conduct trainings, plan shutdowns, and even undertake inspections off-site in a safe environment. Field staff can now have access to experts and context-sensitive knowledge and insights from the twin as they do their maintenance rounds. Here you can see an engineer in the field accessing P&ID documents and IoT sensor data for an asset directly from its digital twin. Imagine all of the business processes that will combine what is physical and what is virtual beyond location boundaries, working in an immersive digital twin environment that allows you to increase asset performance and reduce risks and operating costs through everyday use of trusted information. Now let's shift gears and take a moment to look at industrial digital twins in the engineering phase. In any project, the cost and risk of an undetected design flaw increases based on where we are in the project's lifecycle. Easy and democratized access to up-to-date information is the bedrock of efficient project delivery. Our users, like the one designing this section of a floating production system, are already telling us that PlantSight has improved design collaboration between the traditionally siloed teams. Now all of the stakeholders have the same view of the digital twin, leading to faster and higher quality 3D designs. These models are then being used for handover between engineering and operations, shaving weeks off delivery schedules and bringing higher returns on investment. Issues can be identified in real scale with the HoloLens and verified in the browser. The same data is synchronized between both the environments. Users are already reporting that collaboration with this immersive experience is enabling them to understand their design from a human-centered perspective. With issue management integrated into our desktop, mobile, web, and mixed reality applications, you no longer have to pass files and notes around in emails. All design decisions are electronically captured, ensuring that you not only have a timeline of change for engineering data, but also a complete audit trail of why those changes were made. With our digital twin capabilities, we have taken the suspense out of the design process, ensuring your heart skips a beat only when you see your amazing designs come to life. I really hope what you've seen today excites you and that you're inspired by the larger picture and are as fascinated as I am with the details of building your digital twin. Hi.
So these two links are linked to more detailed sessions regards to the open plant solution as well as plant site. So if you want to look at more details webinars, these two links can bring you there. These are the SRH sessions in our YII event that is currently ongoing. So with that, I'd like to thank you for this short presentation. Now I'd like to open up to any questions that you may have. I think we have about 5 minutes before the next session. Do you all have any questions? Vincent, are you still able to hear me? Okay.
Yeah, we can hear you. So, any questions from the floor? Okay, otherwise we'll just take a 5-minute break. If we are still here, so if you have any questions, you can get to us. And otherwise, you can come back in 5 minutes also to join us for the next session on Autopipe and Autopipe vessel. Okay, so you can also type your questions at the chat box. Okay. Yep, so Tiamat, we'll just stay tuned here. So if there's any questions, yeah, you can answer them. And we'll take a 5-minute break before the next session. Yeah.
Okay, thank you. Thank you, everyone.
Hi, good morning, everyone. Welcome back again. So basically, now we'll be starting the pipe stress and vessel analysis design with Autopipe. Okay, and basically we'll have Mr. Madan from Bentley Systems Singapore to actually present for this session. Okay, so Madan, are you with us?
Yes, Vincent. Can you hear me?
Yeah. So yeah, I think we can start. I will hand over to you, Madan.
Okay, let me share my screen. Okay, can you see my screen now?
Yeah, we can hear, we can see, and can hear.
Okay.
Yep.
Okay. Good morning, engineers. My name is Madan Elimalai, based out of the Singapore office of Bentley. Today, I'm going to give you an update on our pipe stress analysis software, Autopipe, and our pressure vessel and heat exchanger design software, Autopipe vessel. First, we'll look into the pipe stress analysis software, Autopipe. Before I start the presentation on Autopipe, this is the Bentley Digital City, which you could have seen from many of Bentley presenters, where you can see in a typical country, we have high-rise buildings, we have stadiums, infrastructure, we also have process and power plants. And some countries have nuclear power plants, offshore structures also. On the right side, you can see, and various Bentley products like Open Plant and Auto Plant, Autopipe are used for power plants as well as process plants. Okay. And wherein Autopipe comes in here, Autopipe is used in power plants, process plants, offshore structures, as well as nuclear power plants. Okay. And for various other type of projects, we use various other Bentley products. So who are the major customer list of Autopipe? Those companies, global multinational companies who are into either power plant design or process plant design uses Autopipe worldwide. And you can see at the center of this some Malaysian companies, Petronas for owner-operator for offshore oil platforms, and Tenaga National, owner-operator for power plants, okay, also use Autopipe. So what is Autopipe? Autopipe is a pipe stress software. It is market leading in pipe stress analysis. Basically, we can classify the 5 important features that make this product familiar in this industry. Plant safety and integrity to international design standards. Almost any international pipe stress codes are implemented in this program, and they keep on updated with the latest updates in the code. And not just the latest codes, but we even have the old legacy codes also available, just in case if the user want to check a brownfield project which is already constructed, we can use the old code which is designed for. Okay. And quality assurance, this product is quality assured to the highest nuclear software standards. There are many companies who audit Autopipe software worldwide, and they subscribe for a QA version of Autopipe. Okay. And it's very user friendly. So the learning curve is very short. Just 3 days of basic training and 3 days of advanced training. you are all ready to start using Autopipe. But if the user is already familiar with any other pipe stress analysis program, then with a little bit of training and guidance from us, you can easily pick up Autopipe. Interoperability. Autopipe interoperates with many other plant design software as well as structural analysis software like StatPro, plant design softwares like OpenPlant, AutoPlant, PDS, PDMS, etc. So that way we can save time in importing the model from plant design softwares as well as importing the structure, the pipe supporting structure like pipe tracks from structural analysis software like StatPro. And we can also do a combined stiffness analysis in Autopipe, which improves productivity and helps you to do a more accurate analysis because we're considering not just the piping components, but also the structural components. So the stiffness of combined piping and structure will give you a more accurate pipe stress analysis results. The fifth one is exactly the same integration with the STAR and SACS. SACS is for offshore structural analysis software. STAR is for general purpose structural analysis. Autopipe is integrated with both. So the piping codes, we have all the latest piping codes like ASME B31.1. We now have the latest 2018 code also, but rolling back to the old 19967 codes are also available. We have implemented the ASME B31.J code also. It's available for free of cost for our Autopipe users and many other international codes. Okay, so the Autopipe is quality assured in all industries like power, process, offshore industry, buried or cross piping industry, nuclear industry. The graphical user interface has been improved in the latest version. It becomes more user friendly. And the spreadsheets. Here you can see the input grids. Many of our Autopipe users like to use this feature. Along with the graphics, they use this spreadsheet kind of input grids to edit the input. That makes the software very, very user friendly. So basically, Autopipe is a full-featured pipe stress analysis program. It supports almost all the static loads, dynamic loads like eigen solution, harmonic analysis, force displacement time history, response spectra. We also have multiple support response spectra, which makes it unique in the market. And special analysis like fluid transient, thermal transients, and flange design, thermal bowing, steam relief analysis, soil property calculation, etc. Autopipe is well known for its non-linear analysis with support gaps, with friction and load sequencing. There's a separate webinar by myself on this topic. If you're interested, let me know. I can share you the links to watch this seminar on demand, specifically on non-linear analysis with support gaps, friction, and load sequencing. Autopipe is well known for its buried piping because it has the soil property calculator as per many international codes. And that's why Autopipe is well known for seabed and buried piping analysis. Other features, 30 plus international metallic fiber reinforced plastic and high density polyethylene pipe design codes, CAD interfaces to Bentley and third party plant applications, AutoPlant, OpenPlant, Plant Space, PDS, CATIA, Smart Plant Inventor, PDMS, plus others. Includes stress isometric only for the advanced license and nuclear license of Autopipe. Can automatically produce the stress isometrics at one button click. We can also export the anchor loads as nozzle loads into Autopipe vessel and Autopipe nozzle. Autopipe nozzle is free for Autopipe advanced user and nuclear users. Whereas Autopipe vessel is a standalone separate product. Autopipe has the complete structural element library, which is a common element library which we use it in StatPro. So you can model the structural elements directly in Autopipe, and also you can import from StatPro as well as SACS. Autopipe has hanger selection with 27 spring manufacturers library included in this program. Vessel and equipment nozzles, pump, turbine compressor, user equipment plus reference loads all can be input in this program. Extensive material and component libraries for steel, as well as other material pipes, as per many international standards, are supported here. Okay, and this is the new graphical user interface, which is more towards the industry standards like Office 365 look, and any commands or menus. You can always use these icons and menus, but this is a simple search tool for an old user of Autocad, Autopipe, or used to the old interface. If he finds little difficult to switch to the new interface, he can always type in the command in the search tool. That will directly invoke the command, as well as gives you the path to access the icon or the menus, okay, which is very, very user friendly. And most of the commands are CAD-like commands, so it's very easy to pick up. The icons are all customizable toolbars. Here you can see the search toolbar. When you type in the commands, the commands are shown up here. The icons are all shown up here. Coming to the interoperability with Bentley and third-party applications, here you can see for PDMS we have two-way interoperability. Autoplant we have two-way interoperability. And OpenPlant also now we have two-way interoperability. But other programs you can see only one-way interoperability. We can also import Excel coordinates into Autopipe. Okay, and next is the pipe structure interaction interoperability with StatPro. We have bidirectional. We can export the pipe support reactions from Autopipe to StatPro to help our structural engineers to finish their job easily. And then once they finalize the structure design, we can import the structural information from StatPro to Autopipe to do a combined stiffness analysis and to produce more accurate pipe stress design. So this leads to faster design, lesser assumptions, considering of both the structural sway and stiffness, in addition to the piping sway and stiffness. So all leads to more accurate analysis and cost savings, because we are avoiding costly redesign and construction delays by doing a more accurate analysis of combining the stiffness of both piping and structure. Not just with StatPro, but also with SACS, our offshore structural analysis program. The story is the same. We have bidirectional exchange between these two programs, all leads to cost savings. Let's see the productivity gains in modeling using Autopipe. Autopipe uses this segment command, using which we can handle large models very easily by selecting and viewing only the selected segments. For example, here you can see a large model, and the highlighted one in red we are selecting by using the segment command in a spreadsheet, input grids, and then you can click a button to view this part alone. And selecting by segments also helps you to copy it, so modeling becomes much easier. We also have a ring wizard, which allows you to model complex ring modeling. We can also apply your snow loads, wind loads by segments by switching on and off this tick mark in a spreadsheet. All these leads to saving in time. And another very important reason feature is support optimization. This utilizes the cloud computing capability, which currently is available for free for our Autopipe users to use. Almost free. Okay, there is a cap on the free usage, but that cap literally you can call as a big cap. So for new users, that is good enough to use the support optimization feature on a real project. So here you can see a typical layout of a piping assembly. We identified as 51 possible support locations, which are shown in this magenta color. And we have mentioned possible support types plus gaps as 8. Okay. So these are the optimization criteria: 4 stress, 6 equipment, support capacity, and displacement, one each, all adds up to 12 optimization criteria. So this we input into the program using a user-friendly options, and then we submit the analysis to the cloud, and then less than 45 minutes for this project, it shows you this optimization, multiple scenarios by doing adding supports here, removing support, and putting it here, putting it here. So what is the least optimized support out of this 51 possible support locations? Okay, I'll be doing a separate webinar on this sometime in December, concentrating mainly on this feature. Please watch out for that. Now, here you can see after we do this optimization, after the cloud analysis does this optimization, it comes up with the first few options. Okay, and it gives you the cost also and the number of supports. So you can see the first optimized scenario gives you 22 supports out of 51 possible supports. Okay, and this is the cost for that in the currency that you follow in your country. Okay, and this is the sustained stress ratio. This is the expansion stress ratio. These are the support forces ratio, unity check ratios. Okay, these are reference points. It could be anchor points ratio also. So I hope now you understand this feature. When you have a plant that needs to be designed and you need to do the pipe stress analysis, you roughly come up with an estimate of the support locations, but you don't know whether that is going to that's optimized or not. And if you're manually going to optimize it, it'll take several days, several piping engineers working on the same project. But using this Autopipe pipe support optimization, you click few buttons and then cloud does all the number crunching and gives you this optimization. Out of this 51 possible support locations, gives you 22 supports. That is enough to design this project optimized. Okay. So here you can see the final result of with 22 supports instead of 51 possible supports. All these leads to saving in the analysis and design time, and saving in construction cost as well as installation cost, as well as material cost. Okay. Next is a simple example comparing to a competitor program, how to model a guide, a two-way guide. In Autopipe, we just need 4 supports, 4 steps, I would say, to model the support. Click on a support point, insert support icon, click on the support icon, insert support icon, and then select the type from the drop down, enter the stiffness, friction, and gaps. That's it. You finish modeling the guide support in Autopipe. The same support, you need 12 steps in Caesar 2 to model the same thing. You need to click on the pipe in the model, then go to the data sheet, mark point as restraint, then move to the restraint sheet, enter the point name, select type font or restraint. So 12 steps. So you understand how productive you would be in using Autopipe. Okay. Modeling is the important feature of the program that takes time, and Autopipe is very easy to use and you can be more productive by using Autopipe. And even after 12 steps, you see that only one directional gap permitted for each restraint, whereas in Autopipe it supports 4 different gaps in 4 different directions, lateral as well as vertical, and for longitudinal we have line stop support as well. Okay, that's about the productivity gains in modeling. Now let's come into the load sequencing, very important and unique feature in Autopipe. To give a little bit background of this feature, I would suggest you to read this book on pipe stress engineering by ASME Press by Peng and Peng. Okay, so this book was published in 2009 by ASME Press. Okay, sorry. So this book mentions through this chapter, this figure 6.8, okay, that the analysis method used by many pipe stress software was incorrect, and the only valid method was used by programs like Autopipe. So 3 main approaches have been adopted by computer software packages in dealing with systems like the one shown in this figure. Okay. So this book has this in this figure. So here we have a pressure vessel that expands as it operates because of the high temperature. The vessel expands, and the piping which is connected to this pressure vessel through this nozzle also moves up. You see here, as it moves up, the support point 20, you see that initially it was supporting when the plant was not operated, but as the plant was operated, the heat makes this pressure vessel to expand, and then this support point has an uplift. Okay, and slowly after some more expansion of the vessel, this nozzle which is connected to it also moves up, and even the second point is uplift. Okay, so this analysis is simple analysis. The concept of load sequencing is explained by this book Peng and Peng, published by ASME Press in 2009. So in this book, explains that the three main approaches have been adopted by computer software packages in dealing with the system like shown below. Number one is straightforward approach. This is an approach commonly adopted by general purpose finite element programs like StatPro or ANSYS. Okay. And the algebraic subtraction method is our comparator approach. They just simply algebraically sums the results of the results. The third approach is Autopipe approach, which uses an operation condition approach. Operation condition approach means for first the load will be gravity load, and the pipe stresses are calculated and the deflections are calculated. And then the next load is the temperature load, which uses the previous load as the gravity load, and the deflections of the gravity load will be the initial state for the subsequent load cases. Okay, and then after the temperature load is analyzed with keeping the initial load as gravity load, and then the occasional loads such as wind and wave and earthquake are all applied. Okay. So this is the sequence, and this sequence will produce the more accurate results. Whereas in comparator software, all these loads are analyzed separately, and the results are algebraically added or subtracted. Okay, doesn't following the sequence, because all the supports have gaps and friction. Not all, most many supports have the gaps and friction, and hence it is a non-linear load sequencing approach that will give you the more accurate results. Again, I have done a separate webinar on this topic alone for nearly 1 hour. If you are interested more about this, please contact us and we'll give you the link to attend this 1 hour on-demand webinar. Also, this book of Peng and Peng, ASME Press, will also help you to understand more about this load sequencing. Okay. So this book finally concludes that it is obvious that the operating system approach that is used by Autopipe is the only method that meets the core philosophy and requirements. The other two approaches have flaws in calculating the sustained stress and expansion stress, which is used by the comparator. Okay. But note that the book never mentions about the software names. The book always mentions only the methods used in the softwares. Okay. So operation condition approach like Autopipe is the recommended approach. Upheaval buckling. This is another important feature for seabed piping as well as buried piping, which is implemented in the latest versions of Autopipe. Okay, so it occurs after the pipe is laid and under operating conditions. If the force of the pipe overcomes the weight of the pipe, bending stiffness of the pipe, and vertical restraints of the soil cover, the pipe will tend to move upwards, potentially causing considerable vertical displacements like this coming out of the soil. Okay. See here, this is on a good example of buried piping. Okay. It could be potentially dangerous. Okay. And Autopipe latest version gives you this upheaval buckling analysis, and the output gives you this ratio. Asterisk means it is failing in buckling. Okay, and here you can see the required depth. Okay, the program gives you the soil required depth. Okay. Other improvements include the code updates, ASME Section 3 2017 code updates. And we have our other resources like our Bentley Communities link, product page for Autopipe, as well as webinar, tech talk, and special interest group webinars, YouTube videos, etc. Okay. So we have a separate channel for Autopipe stress analysis. Please subscribe to it on YouTube. Bentley pipe stress analysis. It has plenty of videos. Next, we'll move on to the vessel design using Autopipe vessel. Autopipe vessel is used in, again, similar industries like nuclear, power, process, offshore, oil and gas, food and beverage industries. Autopipe vessel has improved accuracy, comprehensive load cases, latest and legacy design codes. We can run cost estimate report, produce 2D and 3D drawings, optimize design, collaborate with third-party applications to exchange data, and easy to use. Basically, 3 versions of this software. Autopipe vessel, which gives you only pressure vessel design option with 1 design code of choice. And now we also have newly introduced Autopipe vessel heat exchanger module, which allows you to design only heat exchanger with 1 design code of choice. Okay. And then the third one is the ultimate one, Autopipe vessel ultimate, which gives you all the options: vessel design, pressure vessel design, heat exchanger design, air cooler design, tank design, storage tank design as per API 650. All codes included. Basically, the product's capabilities can be classified like this: design optimization, shell and tube heat exchanger, tank and air cooler design, cost estimation and bill of materials, comprehensive support design solution, blast and motion load analysis. Before looking at the features, let's see who uses this program, Autopipe vessel. Almost all the major EPCs like Technip, Saipem, Alpha Level, Linde, Arriva, Babcock, Lloyds, owner operators, inspection agencies like Lloyds, etc. also uses our program. These are the major users of a program. Use hundreds of licenses worldwide. Here's a case study from FPSO from Saipem, which is a Euro $4 billion project. Autopipe helped them in designing this pressure vessel in this FPSO, considering the motion load, the inertial load or transportation load, and blast loading. Okay, so Autopipe helps in designing this pressure vessel of this €4 billion project. This program supports almost all the pressure vessel design code and heat exchange design code and tank design code, air cooler design code as per the American code, as well as international codes are supported. The local load designs and standards like PD 5500, which is a British standard, Welding Research Council, which is American standard, EN 13445, which is a European standard, and GHOST, which is a Russian standard, as well as ROC and ZIG formula are all implemented in this program for local load design. And wind load codes and seismic codes, as per various international codes, are implemented in this program. And note that both these are supporting user-defined. In case if the local country code specific code is not available in this program, you can use this user-defined option. For example, Malaysia, we use the British standard, okay, but now it's moving towards the European standard. But you can also use user-defined. Okay. So next, coming to the design optimization. In Autopipe, we have these 2 options to design a pressure vessel. One is the optimized design, another one is check design. And many competitor software has the second option only, check design. Whereas Autopipe has both the option. What is the difference between these 2? Check design means the user input all the dimensions, including the thickness, and the program will say pass or fail. That's it. Whereas optimized design, the program automatically performs optimization and comes up with the thickness. The user don't need to specify thickness. The program comes up with everything. So that is the unique feature of Autopipe vessel. So why do we need to have this feature? Why does the optimization is important? In a typical petrochemical industry, we come across more than 100 pressure vessels, and each and every pressure vessel may cost millions of dollars. So high capital expenditure. Over design or not optimized design means increased capital expenditure. So hence cost competitiveness is critical. Okay. Optimize for material in stock or short delivery. So here is a simple example. We designed this optimization process for this simple conical pressure vessel. A thick conical transition without stiffener ring gives us this cost, nearly $140,000. Okay, and with this optimization, instead of thick conical transition without stiffener ring, the program optimized as thin conical transition with stiffener ring. These stiffener rings are automatically designed by the program, and automatically the program makes this shell, instead of thick shell, it put thin shell. Hence, effectively, the cost came down to 98,000. Comparing that with 140,000, we save nearly 30% of cost reduction. Okay, the program also designs this nozzle design. Both Autopipe as well as Autopipe vessel has this nozzle design feature. Body flange optimization also is available. And here's a simple example of body flange optimization, how it helps you to cut down the cost with various parameters. And comprehensive support design solution. The program can handle any type of supports like saddle designs, anchor at the base, legs, skirt, brackets, conical intermediate skirt, etc. The program gives you a comprehensive foundation load report like this, which you can pass it on to the foundation designer to design the foundation for your pressure vessel. Here's a simple example video of how to use this Autopipe vessel pressure vessel modeling. So you start with this template that it gives you various options like horizontal pressure vessels, vertical pressure vessels, various supports. You choose one of this option to start with, and then fill in the blanks to finalize the geometry. So instead of starting from nowhere, we are starting from a template where the program knows that if you select this option, these are the inputs that needs to be given. So here are the inputs like design conditions, like internal pressure, temperature, liquid level, specific gravity of the fluid. And if any field, if you have a doubt, you can always click on this question mark on the top of this dialog box, and that will open up the relevant pages in the manual to explain you about that particular field. And here are the wind load specifications. You can choose the code and specify the wind load. Similarly, for earthquake, choose the code and specify a few parameters specific to the code. Here's operating conditions. Here you specify the parameters and also the geometry. Specify the diameter of the pressure vessel, the length of the pressure vessel, etc. And give some information about the project to add it in the report. And here's the material database. And here's your model ready, a vertical pressure vessel. Within 2 minutes, we have created the geometry. And now we are modifying the components. For example, the support. I forwarded a little bit. Okay. Next is we modify the cylinder. We split the cylinder, for example, 2 cylinders, and change the diameter of the top cylinder and transition to conical at a few button clicks and analyze it. After we finish the modification, run the calculation. It takes a few seconds for the program to complete the calculation, come out with a MS Word report like this, where you get step-by-step calculations report, including the formulas and sketches. On the left side, you can see the navigation for quickly navigating through the various part of the report. Report also includes the diagrams like bending moment diagrams, deflection diagram, etc. So within 5 minutes, I just explain how to model, modify, analyze, and report a pressure vessel. So here are the dialogues that explains the options for wind and seismic analysis, motion analysis. When we transport this pressure vessel to an offshore platform through a barge, it experiences transportation load. So these are the offshore specific terms like heave, surge, sway in translation. So all these are considered in the motion load analysis, and a comparison of bending moment deflection for wind and motion analysis. Here gives you a table that shows the difference between a normal operation with wind and a normal operation for wind plus motion. And here you can see the difference in results, which is enormous. So that understands that how motion load analysis is important. If you're transporting the pressure vessel through a barge or a lorry to the actual plant, which could be offshore plant or onshore plant. Next is blast load analysis. Nowadays, this is very important. Almost all the projects specifies you to do this blast load analysis. So Autopipe has this capability to consider a true blast load analysis. Next, coming to the heat exchanger design, same like the pressure vessel design, the program comes up with the templates. The user needs to choose your template. For example, on the left side of this diagram, you have this column A, next to the middle is column B, and the third one is column 3. You have to choose an option from A, choose an option from B, choose an option from C, that is to make a heat exchanger design. That makes this program very, very user-friendly. Where to start, where to end, it guides you through this template. And here's a tube sheet layout. You can model complex tube sheet geometry as design cases for tube sheet design. Fabrication level detailed drawings and Solidworks 3D model are the outputs. So here's a short video explains you how to model a heat exchanger. It's a lengthy video of 8 minutes, but I'll forward it to make it faster. So here you do the preference settings of units and drawing format, drawing sheet size, etc. And then you start with the heat exchanger template, and you choose one from the starting of your the head of the pressure heat exchanger from the first column, and then the body of a heat exchanger to the second column, and the end of the heat exchanger, the tail of the heat exchanger to the third column. As you move your mouse along this various templates, you can see the explanation at the bottom. So here we choose 1, 2, 3. That's it. That's okay. And then specify the design code. Okay, from this various options, I'll forward it to save time, and then specify the design conditions, wind load, seismic load, and then the tube sheet bundle information, and material information. That's it. Our model is ready. Heat exchanger model is ready. Various viewing options allows you to view the 3D views as well as the tube sheet bundle, and click a button to analyze and design, produce reports. You can produce the output drawings, 2D as well as 3D drawings in microsession format, Autocad format, Solidworks format, as well as 3D iModel microsession DGN file format. So here's some of the screen captures of 3D iModel DGN. We have 3D detailed drawings. Okay, so here's a short video about the drawing outputs in microsession 2D. After you finish the analysis and design, you produce this detailed drawing, choosing the drawing software as either Autocad or Solidworks or microsession. So this example shows you the first one is microsession. Here's option to produce 3D drawing as well, in addition to 2D drawings, and the units you can choose. The paper size also you can choose. Here's a drawing in microstation. It gives you a complete fabrication level detailed drawing. I forward it to save some time. Okay, so here's a complete sheet. And next, in Autocad, same drawings can be produced in Autocad format also. We support all the versions of Autocad from old versions till the latest Autocad 2021, supported in the latest version of Autopipe. Okay, so that's the 3D model, 3D output in Autocad format. Next, let's see the Solidworks integration. We can first set up the preference. The CAD software, we change from microstation AutoCAD to Solidworks now, and do the drawing production. And this is the Solidworks model created by Autopipe Vessel, which you can open it in Solidworks and view it as well as modify it at a component level. And if the same thing, if we could ask any Solidworks user to model it in Solidworks, you would say 2 weeks to model it. But using Autopipe, we would able to Autopipe Vessel, we would be able to do this in less than an hour. Let me forward it. Okay, so here's a comparison of SolidWorks 3D model creation. On the left, it shows the manual drafting and modeling, which takes 2 weeks approximately. Considering the salary for the model, so approximately you have an approximate drafting cost of $2,460. Okay. On the right side is automatic using Autopipe PASOFAL CAD interface. The task takes less than an hour. Approximate drafting cost of $30, saving of 2 weeks, man weeks. Okay, so coming to the other important updates in Autopipe Vessel, fatigue design. We have some codal updates, and it supports all the international codes. We use the rainflow method for the fatigue design in Autopipe Vessel. And now coming to the most important part of Autopipe Vessel is cost estimation. The program not only designs and optimizes the PASOFAL and also produces drawings for fabrication, but also it produces cost estimation. And here's some sample reports in Excel format. And the user can customize the rates as per your local currency, local country. Next is interoperability. Like most of our softwares, Autopipe Vessel also is interoperable within Bentley as well as outside Bentley. We can import the PASOFAL information from process softwares like Compress, HTRI, AspenTech, ProSim, Honeywell, etc. And then you can continue with the design and detailing in Autopipe Vessel. Okay, so here's a chart that explains how Autopipe Vessel is connected with AutoPlant in 2 ways. Okay, and with PDS, 2 ways. We can also interoperate with Autopipe and Autopipe Vessel for exchange for interoperating the nozzle loads. Okay, so here you can see this is the Autopipe Vessel nozzle properties local loads dialog. we can fill from standard. We can manually input this or submit to Nozzle Pro, which is a third-party analysis program. So that concludes my presentation on Autopipe and Autopipe Vessel, which is a brief one, but if you need a detailed on any specific features, so please contact us. If you need any information on the webinar, on-demand webinar links, which I discussed during my presentation, please keep in touch with us. And with that, I'll open up for any question and answers. Please feel free to ask me, either unmuting your mic or by typing in the chat.
Yeah, thanks a lot, Madan. So basically, any questions from the participants, feel free to either type in your chat box or you can also unmute your mic. Or if you require a trial of the software, do also let us know. And basically, we will be also sharing the recording to some of you. And for some participants who actually join in but can't manage to actually connect, or some that has clicked in the wrong link, okay, we will also share you the recording after this session. So yeah, any questions from the participants? Feel free to type or unmute your mic. Okay, so if there's no questions, basically we'll still be here for the next 5 minutes. Thanks again to Madan for your presentation. But for the participants, if you're in the structural projects as well, design and so on, do join us for the next session. It will be starting at 2 p.m. to 3 p.m. afterwards. So again, it will be presented by Madan, all right? And do stay tuned. And if you still have any questions that you would like to talk to us, just email us or contact us. And we will still be here for the next 5 minutes. So thanks again, everyone, and see you on the next session on structural design solutions.
Thank you.